Hello everyone, and welcome back to the Fluctus Channel. Far from the coastline, an offshore oil rig becomes a steel community surrounded by waves, machinery, and weather that can change without warning. It is not only a workplace, it is where crews sleep, eat, train, exercise, relax, and solve problems while standing above one of the most demanding industrial environments on Earth. A rig may operate hundreds of miles from shore, so daily life is built around self-sufficiency. Helicopters bring workers in. Supply vessels bring food, tools, spare parts, drilling equipment, chemicals, and fuel. Once on board, every person enters a controlled world where safety briefings, identification checks, protective clothing, muster stations, and job permits shape the day before any task begins. Life offshore follows a strict rhythm of shifts. Many workers operate on 12-hour rotations, handing over to the next crew member with notes about equipment status, weather, alarms, maintenance jobs, and any unsafe condition that needs attention. A new shift often begins with a meeting, where supervisors explain the work plan and review hazards. Workers put on helmets, gloves, coveralls, boots, eye protection, hearing protection, and life-saving equipment before stepping onto exposed decks. The work can involve cleaning, inspection, pipe handling, crane signals, machinery checks, drilling support, electrical repair, or monitoring pumps and valves. Each task must be coordinated because one wrong movement near heavy equipment can affect the whole platform. Food is one of the biggest parts of morale. Inside the galley, cooks prepare meals for crews working around the clock. Breakfast may be served for workers coming off night shift while others are beginning a daytime rotation. Hot meals, snacks, coffee, fruit, desserts, and packed food keep workers fueled through long hours. The kitchen crew stores ingredients carefully because deliveries depend on weather and vessel schedules. Dining areas become places where workers relax, talk, and briefly escape the noise of machinery outside. Good food also reduces fatigue, because a tired worker handling valves, lifting equipment, or climbing ladders needs steady energy. Offshore catering teams therefore plan menus as part of the operation, balancing comfort meals with nutrition, storage limits, and the different appetites of crews working opposite shifts. Leisure is equally important because offshore crews live where they work. After shift, workers may use a gym, watch television, sleep, or spend time with colleagues. Cabins are compact, and rules keep noise low so night shift workers can rest during the day. The routine may look comfortable in some areas, but the isolation is real. Bad weather can delay crew changes, and the sea never stops moving below. Workers may spend weeks on the platform before flying back to shore, so discipline is not only about tools and machinery. It is also about managing tiredness, homesickness, and the pressure of living close to the same people every day. The control room is the nerve center of the platform. Operators watch screens showing pressures, temperatures, flow rates, alarms, power systems, gas detection, and safety equipment. If an alarm sounds, the room becomes the first decision point. Operators speak with deck crews, engineers, and supervisors, then adjust systems or begin emergency procedures when required. Engineers support that work by analyzing equipment, planning repairs, checking structural systems, studying production data, and keeping power, pumps, compressors, and safety systems reliable. They may inspect rotating equipment, review drawings, examine vibration readings, or plan a shutdown before a worn part causes a larger failure. On deck, technicians open access panels, isolate energy, tag equipment, and follow permits so repairs happen without exposing the crew to pressure, gas, electricity, or moving machinery. Offshore life, therefore, depends on two routines working together: the human routine that keeps crews healthy and the technical routine that keeps the platform alive. Every meal, briefing, valve check, and control room decision becomes part of surviving daily work in the middle of the ocean, where comfort and danger exist only a few steel decks apart. The rig is home, factory, airport, power station, lifeboat, and emergency shelter at once, and nothing is casual in that daily environment, especially when storms can quickly change every operational plan. Before a crew can live on an offshore rig, the structure must be designed, built, transported, and placed in one of the hardest construction zones on Earth. Oil rig construction begins with surveys and engineering studies. Companies examine water depth, seabed strength, expected waves, wind, storms, reservoir location, and the type of platform needed. A shallow field may use a fixed jacket structure, while deeper water may require a floating platform, semi-submersible, drill ship, or tension leg system. Every choice affects cost, safety, schedule, and how workers will reach the wells. The physical construction happens in large yards, where steel sections are fabricated in pieces. Welders join beams, plates, braces, decks, stairways, pipe racks, and machinery supports. Massive modules are built separately: accommodation blocks, drilling packages, processing units, helidecks, power generation areas, control rooms, and living quarters. Cranes lift components into place, while inspectors check welds, coatings, alignment, and pipe connections. Electrical cables, fire systems, lifeboat stations, gas detectors, pumps, valves, and control systems are installed before the platform ever faces open water. The goal is to complete as much work as possible on land, where access is easier and safer than offshore. Logistics then become the main challenge. A finished platform or major module cannot simply drive to the job site. Heavy transport vessels, barges, tugboats, and specialized lifting ships are used to move large sections across the water. During a move, planners watch tides, weather windows, tow routes, currents, harbor restrictions, and sea conditions. Tug crews connect lines, control speed, adjust course, and keep the structure stable. Even a slow tow can be risky because wind and waves push against thousands of tons of steel. Once the structure reaches the field, offshore installation begins. Jackets may be lowered to the seabed, piles driven into place, and topsides lifted or floated over supports. Floating units are moored with anchors, chains, risers, and dynamic positioning support. Supply vessels continue delivering equipment, food, tools, and replacement parts after startup. Helicopters carry personnel when sea transfer is unsafe or slow. The result is a platform that appears fixed and permanent. But its existence depends on constant movement behind the scenes. Every bolt, food, shipment, worker transfer, fuel delivery, and spare valve must cross the sea before daily operations can continue safely, especially when storms, crane limits, and delivery timing control the next task. That hidden chain of movement is why offshore work feels industrial and maritime at once, with every shipment timed to keep construction, drilling, catering, maintenance, and emergency readiness moving together safely far from land daily. The life of an offshore platform does not end when production slows. It enters one of the most complicated phases in the oil industry: decommissioning. The Brent oil field in the North Sea became one of the best-known examples. Discovered in 1971, the field lay about 186 kilometers northeast of the Shetland Islands and became one of the major oil and gas developments in the UK sector. It was served by 4 large platforms: Brent Alpha, Brent Bravo, Brent Charlie, and Brent Delta. For decades, these structures produced energy, housed crews, supported drilling, and stood against some of the roughest weather in Europe. Brent Charlie was one of the giants of the field, with accommodation, processing equipment, drilling areas, pipework, power systems, and a helideck rising above the sea. Life inside followed the same offshore pattern of meals, shifts, briefings, machinery checks, and strict safety control, but shutting it down required a different kind of discipline. Final preparations meant isolating systems, cleaning equipment, removing hydrocarbons, checking electrical supplies, securing wells, and reducing the platform from a working production site into a structure ready for dismantling. Workers also removed loose materials, labeled equipment, planned escape routes, confirmed lifting points, and separated systems that once operated together. The goal was to remove danger before heavy lifting began. The most critical work happens below and inside the platform. Wells must be plugged and abandoned so the reservoir is safely blocked. Engineers place barriers in the wellbores using cement and mechanical plugs, verify isolation, and make sure fluids cannot escape. Pipes are flushed, tanks cleaned, and equipment made safe. Weather adds constant pressure. North Sea waves, wind, cold, and limited daylight can delay lifting windows and force crews to wait for the right conditions. A heavy lift cannot begin just because the calendar says so. It must match the sea, the wind, and the lifting vessel's limits. For Brent Delta and Brent Bravo, Shell used a single lift method with the giant vessel pioneering spirit. Brent Delta's 24,200-ton topside was removed in one piece in 2017, an operation described as the world's heaviest offshore lift at the time. The ship positioned itself around the platform, connected lifting beams, cut the topside free, and raised it in seconds before carrying it away for dismantling and recycling. Brent Bravo followed with another huge lift. These one-piece removals reduced the amount of cutting offshore and shifted much of the dismantling to safer onshore yards. Brent Alpha required a different approach because its structure and supporting jacket were different, so sections had to be handled with another plan. Brent Charlie also demanded careful preparation because its size, remaining systems, and location made every stage dependent on weather, engineering checks, and regulatory approval. Decommissioning is reverse construction under worse conditions. Crews must remove what earlier generations built. But now the steel is aged, systems are emptying, and the sea is still fighting every step. From daily life on active rigs to construction yards, towing routes, shutdown crews, plugged wells, and single lift removals, the story of offshore oil is a full life cycle. The same platform that once fed a nation's energy network eventually becomes a careful dismantling project, proving that the final chapter of offshore engineering can be as demanding as the first installation, demanding patient planning, precise lifting, and respect for the sea at every single final stage. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.